Hello, yes, welcome back to another video. In the last videos, we looked at different schematics diagrams, we looked at different pages. So in this video, we are going to look at Power Up sequence diagram. As you can see in the background here, it says Power Up sequence diagram. This is one of the most important part in schematics diagram. You know, all the things we have been covering in the recent videos, they all make no sense if you don't have this information. And don't take me wrong, but I'm going to explain to you why. Because we have seen different voltages, we have seen meaning of different abbreviations. But then, what's the point of using a schematics? You know, the reason why we are learning how to use a schematics is because we want to solve problems or fix motherboards or fix computers. So this topic talks about how to actually use the schematics and fix the problems. Now, as you can see here, so at the corner here we have these colors: red, which means power rail; orange, which means output from KBC, these are signals; and then light blue means output from CPUs. So these power up sequence diagrams explain the steps that a motherboard takes to power on. So basically this explains step by step what the computer does from the moment you plug in your charger to the moment you press your button to the moment the laptop displays on the screen. So this is very useful, especially when you're fixing laptops that do not turn on, or when you're fixing laptops that turn on briefly and then go off, or laptops that turn on and give blinking signals, like you see some caps lock is blinking or some other light or charging lights are blinking and the laptop is not displaying or is not posting to the screen. This is the best place to start for you to easily fix those problems. So after these signals, you can see here that we have different letters that are in blue circles. And if you are not mistaken, you see that we have A, we have B, we have C, we have D, we have E, and here we have numbers. So the steps that the computer takes to boot on, they are organized in alphabetic orders. As you know that letter S is the first letter in alphabetic order, so the first step that the computer needs to start operation is put in letter A. And here you can see letter A, we have what we call DC battery. And on this box they show you where you can find a DC battery. It's on page 43. Here on letter A still we have AC adapter. So this one represents the battery and this one represents the adapter. So here it shows that the power from the battery is called BT plus and the power from the charger is called DC in. So that's the first step. So here it means that before the laptop does anything, either of those two should be present. Either there should be a battery or there should be a charger. As you know, laptop cannot turn on unless either of the two is present. When these two are present, we see that the battery has got another chip here, where the battery goes through to come here. And then the same goes to the charger. It has another chip here where it goes through, then it goes to the charging chip. So at the charging chip, we see the charging chip gives out what we call SCOK, which in the last video where I made the meaning of these symbols and the signals, we saw that power, charger, OK. So we saw that SCOK means power, charger, OK in that diagram. And actually, if you did get that document, I will put a link around here and you can download that document. It explains all the meaning of these signals. So after A, on B, we see that after the power from the charger goes to the charging chip gives out B, which is SCOK. This signal goes into another, this is actually a resistor. You see it's called R2469. After it goes through this resistor, it comes to the EC. So you see this one's called the KBC MEC 1404. And then tells the EC, because you can see the arrow shows that it comes from the charging chip to the EC. And then this shows power supply in. So this L shows that the power supply has been inserted. So here on C they show that the EC now gives out a signal that turns on the arrays. So after the EC has seen that the charger is in, it gives out what we call always on, which means this is the signal that is going to enable 3.3 and 5 volts. So you can see here that from C we have D, and then this D goes out of here and comes here on this chip. So when it comes here, you can see it has got enable 1, enable 2, which gives out 3.3 volts S5 and 5 volts S5. So after D, we have E, which gives out this voltage you just seen. Then we have F. So F shows that after this chip has given out these voltages, it gives out a signal which comes out at F, and this signal is called 3 volts and 5 volts POK, which means 3 and 5 volts power OK, basically indicating that the volts have come out and they are fine. Now let's see where does this signal go to, because it according to the arrow it shows that it comes out of that chip. So F comes out here and gives out to one resistor, which gives what we call RLSM reset power good. But this one comes out at H. So before H comes out is F G. So after this F is here, it also comes here, right? Then you have this G, which remember the other volts that we made on top here, which were on E. So those voltages come here, and then F turns them on, and then G they come out, which is 1.8 S5 power OK. Remember, all these steps are taking place before you press your power button. After G is up, you can see here, and then here it shows that this same signal called F comes on two chips. It comes onto this one and comes also on this one. So this one gives out 1.0 volts. Okay, this is 1 volt S5, and these also come on G. Then the next letter is H. So these G that have come here, they also part of them comes onto these resistors. I'm saying they are resistors because there is R inside here. So as you can see, this is 1.8 S5, which is here, and this is 1.0, which is here. So when they come here, they all join up together to make H, and H is RSM reset. So RSM reset is a signal that, let's see where it goes. It comes to the KBC or the EC. You can see it here, right? So when H comes up here, let's see. Oh, actually, wait. Before F going to G, we saw that there is another F here, which means when F comes out here, we also have another F that goes out of the KBC to the chipset, right? So this is the chipset. So F also goes out from there to the chipset. Then the G comes up, and then you have the H here. After H, we have I. Now, here it shows that after these signals come to the EC, then the chipset gives out this signal back to the EC, and this come at I. So we can look around and see, is there anywhere else where I goes? And here we don't see any I. So it means when I is out, it comes out of here on these pins and goes to the KBC. So after I has come out, we look for J. So when you try to look around, we don't see letter J. That means the power up sequence switches back to numbers. And when you look here, you see there is number 1. So number 1, if you look closely, it's called the KBC power button. So all the steps we have seen from A B, C, E, F, D, H up to I. All those steps take place before you press your power button on the motherboard. So if you have a motherboard that is not doing anything, is not turning on, these steps here we have seen can help you to fix your motherboard. So what you will do, you start with A, you check, is the charger in? Is the battery in? Yes. Okay, if it is in, is the battery charged? Does it have enough voltage? Okay, if it has, is the charger inside? Is the charger charging the battery? Yes. So is the charging voltage, the battery charger on? Yes or no? Okay, if it is yes, you go to the next step. You go to B. Is the charging chip giving out SOK? Yes. Okay. Does it go through the resistor to go to the EC? Yes. So after B, you go to C. Is the EC giving out the signal to turn on the 3.3 and 5 enable? Yes or no. If it is giving out, does this signal also reach this chip? You check for enable, you check if it is yes, that's good. Does this chip give out 3.3 and 5 S5 as it's shown here on A? Yes. Is it giving out F to tell the chip that power is okay? Yes. Does F come to these chips to make this voltage which are on D? Yes. If it's okay, do they come here to make this RMS power good back to the chipset? Yes. If all those steps are there, then the only thing that a motherboard will be waiting is the power button. So that is what they call a power up sequence. Oh, this is the main guidance on how to use the schematics to solve issues.